It was too ordinary. Sorry.
Yeah. Yeah. Am I sharing the screen?
No.
No, not yet. All right, folks, welcome back. Today is our third session on the AI agent course. It's 29th of August and Thursday evening, 7:20 p.m. now. We are starting a little bit late, and I apologize for that. Um, now, so far, we have been through, if you look at the course, we have been through this concept. What are AI agents? And as we thought about AI agents, it goes back to a lot of decades of thinking about, I mean, it goes almost to the heart of what is artificial intelligence. And when we think of agents, we think of agents as the intelligence that basically gets input from sensors and then uses actuators to do something in the physical world or some external world. Right? With that basic notion of an agent, it has evolved quite a bit. People, even then, long ago, already could see that if you have a lot of agents with these sort of properties, you could start seeing emergent behavior, you could start seeing many, many things. So, just as a quick recap, we have those videos, but uh, you can find lots of awesome papers out there and code and so on and so forth. I won't go into those at this particular moment. Next is you did some labs, which was the lab on creating a glossary and a business plan, isn't it? And then you went through a solution. One of the things that you did is you tried to use um, AutoGPT. We said, how would you do it with AutoGPT? AutoGPT was a single agent framework, if you remember. There was only one agent that iterates things, interacts with you, reasons, reaches out to the world with tools. So you had some of the components of what we would consider multi agent collaboration, isn't it? And the reason I introduced it is because I said it is the most basic framework. But what I was getting into is a world, the far more fascinating world is the world of multi agent collaboration. Last week, we read the paper, Simulacra paper, and I hope you recall that it was a very impressive paper. You could, you could simulate much of human sociological behavior, social behavior, by considering a group of or a small village of 25 agents, just 25 agents. And you saw most remarkable emergent behavior. You saw that people changed political views, people stood for election, people fell in love, people threw a spontaneous Valentine's Day, or rather, these are agents, threw a spontaneous Valentine's Day party. And then everybody showed up. Lots of people showed up to the party and they found dates to go to the party, to the Valentine's Day party. It was almost remarkable. And that brings out to the fact that it is far more interesting to look at multi-agent collaboration to do things. And I'll just quickly go through the slide deck we went through. Um, what are agentic? So inherently, we want to talk about cooperative games within the team. That is the lens through which I look at it. I think of the power of agents coming not from one agent, because just one agent, as you will see in a paper we'll read, you could actually do quite a bit with a systematic process of reasoning, thinking, acting, observing, and so forth. So the real power of it comes when you treat a group of agents as a team that is playing a cooperative game from a game theory perspective. That's the way I like to think about it. And when you do that, you often see that these things, very much like birds in the sky, they do show emergent behavior. when you do such a team, in highly effective teams, you want specialization, very focused and well articulated roles. Each player has a raison d'etre, why you have this, some very unique and differentiated contribution each player brings to the team, or therefore an agent brings to the team. And we talked about the shapely value that each user, each sort of agent must contribute a non-zero and substantial shapely value. And the collaboration has to be flawless. People have to understand what the rules of collaboration are. By people here, I mean the AI agents. It must be very clear to them. There should be no ambiguity. And but and also the specialization of work, roles, tasks, etc. So I summed it up in this is sort of my way of thinking, the key characteristic of multi-agent collaboration. And we'll do that because today it will become very relevant and practical. Planning. You saw some example of planning in the last week's lab, isn't it? You have task decomposition. It tries to break it down into tasks. Coordination, you didn't see that because AutoGPT had no the thing. But today you'll see examples of coordination and collaboration because we'll enter multi-agent. Critique and reflection, you saw some part of that, right? You saw some bit of memory implicitly there. And then you saw the fact that it's using tools to search the web and to do things. Or then sensors are, of course, ways to get information. So keep this. The reason I'm bringing this blueprint is we're going to use this blueprint. This is my pattern. And today we'll talk about a framework, CrewAI, in which we'll take a few examples in which it will systematically touch upon all of these points that I have, which is one reason I tend to emphasize that. So I won't go back to why agentic reasoning, etc. You know that it works. It's closely aligned with human way of doing it. It's getting a lot of adoption. Many use cases, personalized customer support, etc. For example, this one, you'll actually see it in action today. Many different use cases are there, but we won't get into. This was a paper we talked about, right? And today, AutoGPT we already did, but today we'll talk about this one, CrewAI. This will be our focus today. Later on, we'll do AutoGen and PhiData and other ones. But CrewAI is, by now, you must have realized, it's my favorite and a very powerful framework to get started. It gets a lot done, and we will focus on that. So I would like to, before I go into the framework, we'll divide our today's talk into two parts. In a very short half an hour, I would like to talk about a paper, as always, take a literal theoretical dive into one of the original research papers that in some sense is a precursor to things like CrewAI. You can see the germs of many of the ideas in multi-agent collaboration and so forth. And you see some of it in this paper, REACT. It is often spelled as REACT, Reason and Act, or the more formal title is Synchronizing Reasoning and Acting in Language Models. Right? So we will talk a little bit about this paper, and then we'll talk about CrewAI, and we'll look at examples of CrewAI. That's our plan for today. So with that as our plan, let us now, and then at the end of it, I'll give you guys some homeworks to do. Right? So what is this, and how do we, let me make sure that nobody's waiting. All right. This paper is it was quite influential actually in the world of prompting. And of course, prompting, we have quite a bit of overlap to this agentic thing because agents are defined through prompts. While large language models have demonstrated impressive performance across tasks in language understanding and interactive decision making, their ability for reasoning, example, chain of thought prompting, and action plan generation, has primarily been studied as separate topics. In this paper, we explored the use of LLMs to generate both reasoning traces and task-specific actions in an interleaved manner, right? One after the other, allowing for greater synergy between the two. Reasoning traces help the model induce, track, and update action plans as well as to handle exceptions, while actions allow it to interface with and gather additional information from external sources such as knowledge bases or environment. So you see that it's using tools. It's going to gather information from the external environment, right? But and now it is not an agent. It is just a framework to use LLMs at this particular moment. Think of it like that. We apply our approach named React to a diverse set of language and decision-making tasks and demonstrate its effectiveness over state-of-the-art baselines in addition to improved human interpretability and trustworthiness. Concretely, on question answering, pot QA, and fact verification, React overcomes prevalent issues of hallucination and error propagation in chain of thought reasoning by interacting with a simple Wikipedia API. So Wikipedia API is a tool, right? And generating human-like task-solving trajectories that are more interpretable than baselines without reasoning traces. So they're using the formal term reasoning traces. You see how it is reasoning, how it is thinking, what the thought process is. Furthermore, on two interactive decision making benchmarks, React outperforms imitation and reinforcement learning methods by an absolute success rate of 34% and 10% respectively, while being prompted with only one or two in-context examples. This is very important. It turns out that if you follow the React, you don't need lots of examples. With just a couple of small examples, you get away with it. And we will get into that. Now, I want to quickly go over the paper, so I will just focus on this example. Let's look at the first example. It comes from the Hotpot QA benchmark data set. And what it is it's saying, question, aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with? You realize that it's a complex problem, right? It's saying Apple remote was used to control something, some device. So they're asking what other device can control whatever it is that Apple remote was originally designed to interact with. So if you just ask it as a, if you asked a LLM at that time, they used Palm 500 million or 550 million or whatever, a large model. It came back with the answer iPod. So obviously, a very simple prompting, giving it a question, does not elicit the right answer. Right? So you don't use the Apple remote to interact with the iPod. Or aside from that, what other devices can control the program? Oh yeah, what other devices? iPod? No, that happens to be the wrong answer. Chain of thought reasoning. Now we remember that we talked about chain of thoughts, step-by-step thinking. Right? An example of few short learning. Let's think step by step. Apple remote was originally designed to interact with Apple TV. Apple TV can be controlled by iPhone, iPad, iPod Touch. So the answer is iPhone, iPad, iPod Touch. This answer too happens to be wrong. So chain of reasoning, chain of thought reasoning is also not working, isn't it? It's a very powerful prompting technique. If you are with me, I think you are taking the LLM too, isn't it? So we covered the chain of thought research paper, if you remember. So now there we saw its successes. Now you see its failure. It doesn't work for a problem this complex. Now you can do, so people have tried chain of thought to help it reason better. But there are frameworks that just are action-based, act on. So let's try. Search. Just use the tool. Keep using the tool till you find the answer. Search Apple remote. And then you observe what you get. You get the Apple remote is a remote control dot dot dot. Then the next thing is you search for, okay, front row, because it says it was used to control front row. And the observation is could not find front row. Similar. Yeah. Act 3, next action is front row software. Now you saw a software, and then it says front row is a discontinued media center software. Right. And so you come to the conclusion, action 4, just finish. Done. Well, that's not an answer. Now, the method that this paper proposes is it introduces the concept of a thought. Right? Think of thought as an action in the language space. If you think about it, that's in a way, when we think, we are putting some words together. It's an act of putting or stringing some thing together. So you thought. The thought is, I need to search Apple Remote and find the program it was originally designed to interact with. So that thought is pretty good plan, isn't it? To answer the question, what was it originally designed to interact with? What other devices were. So before you find out what other devices interact with it, you have to first find out what that program itself is. So it goes through the action. Now observe how the action is action 1 here and action 1 here is the same. Right? It elicits the same response, front row media center. Then it has a thought. Now, if you compare act only and the chain of thought with what does the chain of thought have? Chain of thought has thoughts and action has only actions. But it is saying by interleaving thoughts and actions, see what happens. Then you have another thought. Apple Remote was originally designed to control the front row media center program. I need to search front row next and find what other devices can control it. That's all you need, isn't it? So it goes about searching for front row and concludes, could not find front row. Similar front row seat to earth, front row motorsport, front row software. Okay. So it realizes that the best thing it can do amongst the 3 choices is it has a thought that it needs to search front row software. So it searches front row software. Then it comes to the conclusion that front row is a discontinued media center software. And so front row, it has a thought, front row software is controlled by an Apple remote or the keyboard function keys. Right? Most software are. So the answer is keyboard function keys, and it says finish. The other way you can interact with that program is using the keyboard function keys. Does that make sense, guys? Right. And so that happens to be the right answer. But see how it carefully planned. It ended up answering a very tricky question, a very indirect question that couldn't have been answered without some searches, without some action, and without something. And that is the power that they are trying to, this paper is eliciting, that think, act, observe. And you see how there's an interleaving of these, isn't it? So let's look at another problem that this approach solves. And by now you must be seeing that the world of prompting has been thought through very, very deeply. Right? This was already last year. Alfwold, you're in the middle of a room, looking quickly around you, you see a cabinet 6, a cabinet 1. So you see cabinet 1, cabinet 6. A coffee machine, a countertop, a stove burner 1, and a toaster. So you see these things. Your task to do is to put some pepper shaker on a drawer. So put some pepper shaker and put it on a drawer. So if you try to do act only, it would go pretty badly actually. So it says go to drawer one. Drawer one is closed. Okay. Open drawer one. You open the drawer one is open. In it, you see a dish sponge two and a spoon. That didn't go. That's not helpful. Then it says go to sink basin one. On the sink basin, you see a dish sponge three and a spatula and a spoon two. So do you see a pepper shaker there? You don't. But nonetheless, this thing now starts hallucinating and it says, take pepper shaker one from sink basin one. It wasn't there. Right? And then its observation is nothing happens. And then it says, take pepper shaker one from sink basin one. Observation, nothing happens. Pretty much it's going nowhere. It's gotten into a loop, isn't it? Nothing happens because in the real world, you're hallucinating. There is no pepper shaker there, right? You cannot actually act or change the world in realistic way, right? So in other words, you're grappling at an imaginary object. If you imagine that the robot is doing that, the robot will pick nothing in effect, right? So now let's look at the react way of reasoning through this. It is that think first I need to find a pepper shaker more likely to appear in cabinets 1 to 6 and countertops. Well, it's probably reasonable, right? You'll find it in the cabinets or countertops. You're not likely to find it in the toaster or the stove burner. Right? So that's a pretty logical thinking where not to look. So it goes to cabinet 1. On the cabinet 1, you see a vase. Here the agent go to cabinet 1, then cabinet 2, 3, then countertop 1 and 2. So it keeps going there. And then it goes to countertop 3. On countertop 3, you see, so the observation is, because when it does that, it sees, imagine that the robot is seeing that. You see an apple 1, a bread 1, a pepper shaker 1, and a vase 3. Well, it found the pepper shaker, isn't it? While looking through it. Act 7, take pepper shaker from countertop 3. Observation is you picked up the pepper shaker 1 from the countertop 3. Now, Act 8, think, now I find a pepper shaker 1. Next, I need to put it in drawer 1. It just needs to put it in drawer. Go to drawer 1 is closed. Open drawer 1, you open drawer 1, put pepper shaker in drawer 1. Observation, you put pepper shaker 1 in on the drawer 1 and it basically finishes the task correctly, right? So this is pretty much what React is. And I can go into more formal way of looking at it. And I'll just do it just this little bit because this is the way you think in the world of agents. Because you see that with this LLM, you already see the word agent come up, isn't it? And this must be looking very familiar to you from what you just did in the lab 2 days ago. Does it look very familiar? Right? Is it looking very reminiscent of what you were just doing? Right? It is not exactly the same because long-term planning is missing. But, and that's why I say that this paper is in some sense a precursor to the things that came. And I'll just read this paragraph. Consider a general setup of an agent interacting with an environment for task solving. At time step T, an agent receives an observation, OT. So at any given moment, it observes, takes an action, and follows some policy. Policies are optimal policies. Like once you observe and you act, there are infinitely many actions possible. So you have to pick an action. Your best action that you pick in these environments is there's a policy that will tell you this is the best action. Right? For example, it observes that there are drawers and there are countertops and there's a stove and there's a toaster. What is its policy telling it? You're much more likely to find a pepper shaker on the drawers or the countertops, isn't it? And not inside a toaster or that. So that is a policy of action. It is telling you that if you start looking into the cabinets, right, or the drawers of the cabinets, and the countertops, those are preferential actions. So a policy in a more formal sense, is what recommends you the right action to take. Right? Given a context, so the policy says that this action is preferable, action T is preferable given the context at time T, right? What the real world is or what the situation is at that moment. The problem is learning a policy, and this is the crux of the matter. And by the way, forgive me if this is getting a bit academic, but I'll just finish it because it states it pretty elegantly. Learning a policy is challenging when the mapping from context to action is highly implicit and requires extensive computation. So this is not something you can do. And this is where obviously large language models shine because they have descriptive knowledge. For example, the agent shown in blah is unable to generate the correct final action, etc., etc. We'll care. The idea of React is simple. We augment the action space. So remember, what is it? You observe, you act. That's the agentic behavior. What it is saying is we augment the agent's action space to a hat, which is the action in real world and action in the language world. You do something with language. Where L is the space of language space. And action, therefore, in the language space, action in the language phase, they call it a thought. They say, we'll call it a thought. Right? And it looks very abstract, or a reasoning trace. So in this paper, they use the word reasoning trace. And you'll find that many other people in many situations tend to use this vocabulary. And as you do this agent, you will literally, did you see that thing, thought? Did you see that come up in your agentic framework? Right? So you'll certainly see it as we do the today's framework. So,
Asif?
yeah.
So action, thought, and reasoning, they're all are part of that big A that you talk about. So it could provide you a chain of thought, or it could provide
Yes,
you
very
reasoning.
much. Yes,
Okay,
it could.
okay, okay, clear. Thank you.
So action could be like pick up the bottle, right? It's a real action in real environment. Action could be search the web. Action could be scrape a web page. Action could be look it up in Wikipedia. Those are action. But when you do an action in the language space, you're thinking. That's a thought. One or more thought.
Thank you.
The actions are associated with tools. The only way you do actions is with some tool. LLM, exactly. And that is why this paper is all about, and it using basically what it is saying is it's a thing that works really well. This paradigm of react, reason and act, right? So reasoning is what? It is not just acting, right? Reasoning, it's not just acting and observing. It is reasoning. Reasoning is an action in the language space, and for that, of course, you need a language model. That's the main idea of this paper. So when you do that, I won't go into the rest of it. The suffice is to say that the results are quite impressive. I'll just finish this one line. Instead, a thought aimed to compose useful information by reasoning over the current context and updating the context, right, with further action, etc. So you see that, this examples illustrate it. When you observe, you think over that observation. That is an action in language space. You draw some conclusion from that, some reflection from that, isn't it? That is it. And so that is all. Suffices to say that this paper, when it came out, it was got quite a bit of attention, and in many ways was a motivator from all these frameworks that were coming up. Right. Now you will see that this kind of thing has a strong resonance, I would say, with LangChain, all of these agent frameworks, etc. They have a very close resonance. The only thing that this paper is missing, I suppose, first of all, it's a single agent paradigm rather, not frame, paradigm. The second thing is it doesn't have a lot of planning built in. The reasoning is not fully developed into planning and so on and so forth. So there are some things. That's why I consider this paper to be a precursor of things to come. The things that you grow up into full agents. But when you first come to agents and you see those machines emit out statements like, let me think, oh, I think this is what we should do. Right? You're getting a sense of how these LLMs are capable of thought based on certain observation and therefore of coming up with a plan of a subsequent action. Right? So that is all I would say about this paper. It goes on. The benchmarks are obviously pretty impressive. It's able to beat things hands down quite a bit. Right? And mhm. It starts with the thought. The first action that it does is in the language space, right? It thinks, it reflects. What should I do? It reflects on what? The question. No, you just, yeah. So, in a way, right, you force it into that cycle that whenever you get an input, first think, then act, then observe, and then think again. Like interleave thinking, reasoning, and action. Reasoning and action. Yeah. Yeah.
Ask if the problem
One
is
second, Albert, 1 second. Go ahead, President. Yeah. Yeah. Yes. You pretty much put it, think of it as a programmatic loop. You put it into a programmatic loop. Right? You give it a prompt, you say, think now. Here's the query, think. Then it thinks. Then it says, what's your action? Then it says, yes, it's a loop. Yeah. Yeah. You ask it to give you an action. And the action it comes back, it says, go search Apple. Search, use the search tool and search the web. And then you search the web and then the results that come back, you give it back to the LLM and you say, okay, here's the response. Here's the observation that came back. Now think again. Now time to think, right? And then propose an action. Think and propose an action, right? No. Yeah. 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 See, it has, whenever it gets an action in this paper, it says that it is allowed only basically 2 or 3 actions. One of them is search, action, and the other is finish, of course, to terminate itself. There was some other action, I forget. But basically, think, right? Think, search, act. Yeah. So if you look at this one, in this one, it thinks. Act is a thought. Then actually, it should just have said thought. A thought, action, observation. Then it realizes that given the observation, all it needs to do is continue its journey, keep acting. It has to look into first cabinet, didn't work, second cabinet didn't work, third cabinet didn't work, fourth cabinet didn't work. Go to countertop 1, then 2, then 3. Okay, I found it. Observation is you found it, right? Because here is the paper shaker. Programmer, yeah, programmer has done. So in other words, you have a code. Your agent is a programming code. The agent has been told that you must follow this reason and act, reason and act, reason and act. Means reason, act, observe, reason, act, observe, reason, act, observe, right? Go through this chain always. That is it. So in other words, another way to say it is that little bit of code that forces a LLM into this loop, a tool and a LLM into this loop, is an agent. Has become, and you see the prototype of an agent emerge from just this little loop that they're tied into. And that's why it is, the title of the paper is Synergizing Reasoning and Acting in Large Language Models. Like you interleave reasoning, acting. And of course, acting always leads to observations, right? Because you act with the tool, something will pop out, right? So that's it. Yeah, reasoning is an action in the language space. Yeah. See, action is, there are two kinds of things he can do. Think about it this way. The LLM is allowed to use only tools. Let's say that it is only act to act, suggest an action, right? It can suggest an action using the only tool available to it, search, another action, let's say finish, a third action, think. At any given moment, the LLM needs to decide which of the three tools to use, right? Think, search, finish. So it starts by first saying think is a better option. So then what will it think on? It is given the only context available for it to think on in the beginning is the question. So it needs to do the think action. Seeing that, right? Then follow it up with another action, right? Right after the thinking like suggests that you need to search the web, isn't it? So look at the thought. I need to search Apple Remote and find the program it was originally designated to interact with. So now that it has thought that, done a think action, you ask the LLM, what's your next action? Think, search, finish. It will say search, isn't it? So you go into search mode. Then it comes up with observation. You append it to the query, like now this, the thought, the observation, all three. Now you have a longer context, isn't it? The question and these things, thought and the observation are the context. Now you ask it, what now? Think action, search action, done action, finish action. It will say, well, I'm not yet there. So think, right? Then it thinks and then it realizes it needs to search. So it is in a loop, it is just picking the right tool and doing it. One of the tool being thinking, one of the actions being thinking. Now is it making more sense? That is it. No. Thought is called the reason. Yeah, that is, thought is the reason, and also reason is also, I suppose, in some sense, implicitly picking whether to think or to act, right? Because it doesn't always think. If you look back, at some point, right here, look at this. It is not thinking. At some point, it is just acting. It is not done acting because it's in a loop, looking here, looking there for the pepper shaker, isn't it? Because it's very right away, it's clear after the first thought, first thinking act, it is very clear that it needs to act on every countertop and every cabinet, right? Otherwise, you need to be sure whether the pepper shaker is there or not. Where is it? And so it does that, and then it decides, okay, we need to do that. That's why this whole process is called reason and act. But a very close approximation would be to say that to reason is to think, right? Think, and action in the real world is the act part, and action or the think action in the language world is the thought or is the reasoning. That's one simplified way to look at it. So are we getting it, guys? And I hope you see why this paper is rather apropos when we talk about agents. You see the ideas that it inspired, especially with LLMs. So I would, yeah, yeah, Albert, sorry, you're waiting. Yes, go ahead.
So basically, this can be achieved, right? So you want your agents to achieve this React functionality. So you are
More than that, Albert. Today, like when we think of agent, we think much more than that. So two things we differ. Remember, and that is why I gave you. Now let's contrast this paper to the framework that I gave you in this. Let's go back to that slide.
So my question
Let's.
here is, this can be achieved. It doesn't come out of the box, right? You have to prompt it or find a way of doing it.
That
Correct?
is right. That is right. That is right.
Okay. Okay.
LLM doesn't. So basically, that programming loop that you wrote to force it into this mode is the React
Okay.
programming.
Okay. Clear
Right?
enough. Thank you.
And think about it this way. See, if you look at LangChain agent, etc., right, you will see that there is a very close. They are very close cousins of this paper. What is it? It's a bit of Python code that is forcing a sort of a workflow like this, isn't it? Right? And so now look at it. Which of these elements of agentic reasoning are there? Planning. So thinking would map to planning, I suppose, or reflection. Between planning and reflection is your thinking, isn't it? That's what they would map to. Tools is the action part. You use it to act and think, and action in the language space is planning and reflection. So those two things are there. So as you can see, it looks here, 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 here. Yeah, some elements of task decomposition is here. So I always use this as a rubric to see to what extent something has achieved what I would call full-blown multi-agent or agentic reasoning framework, right? So you see the ideas here. Yes. Yeah, that is right. Because it's modifying the context, right? It's updating. So there's a planning and critique reflection are there as part of thinking, and tool is there as part of acting in this. So, and memory is implicit because you have to keep appending the context. So the context is in the memory. So quite a bit of things are there. Some level of task decomposition is there. What is missing is the multi-agent part. It's a single agent doing all this. There are no multi-agents. And therefore, there is no collaboration or coordination happening. Right? So guys, that was this paper. Let's take a 5-minute break, should we? Or should we just plod on? What would you like? 5 minutes break, huh? Let's take a 5 minutes break and then we will go and now get into the next and what I consider one of the most exciting, practical agent frameworks, multi-agent frameworks. The one that I intend to like quite a bit. We'll get into it.
Asif,
Go ahead.
I attended the Princeton University agents workshops today.
Right.
Is prominent people that actually spoke. So the heavy focus there has been the SWE agent. They were constantly, pretty much everyone was touching about it and re-emphasizing that, that's where most of uh, the innovations going in,
Oh,
trying to help the software engineer. So just wanted to let you know that.
no, definitely. SW agent is obviously is Princeton's creation. If they organize a
Right.
if they organize a workshop, that's what they'll talk about. But
Right.
certainly, see, frankly, right. I like the paper is amazing. When it came out, it's just I mean, sorry, the GitHub and everything is amazing. I think that it's really awesome, very creative. Now, uh, Actually, that's a very good idea. Why don't we add it to this course? Let's cover that also. From a very practical perspective, Madhu, like if you look at what people are actually doing in the industry, you will see that more or less Crew AI and AutoGen have captured the mindset simply because they're easy, they're straightforward, they're not so researchy. But Sui is, I mean, Sui is of course amazing.
And the professor that led this in a whole workshop, he has a book that's coming out, so it's on
Oh,
pre-order right now. It's called I actually placed the order already.
oh,
AI Snake Oil.
AI snake oil. Oh, that seems like
Yes.
popular science book rather than a technical book.
Well, it's talking about the from a safety perspective. So it's more of a AI safety
That's
context.
right.
You
Okay.
know, it's on pre-order right now.
Nice. I think I'm
I'll
going
let
to
you know
just
once I get it.
I'm going to listen to it on Spotify on my walks.
Okay. By the way, you're still on record.
Yes, that's good. I tend to listen to like books that are narrative. Simply, I prefer that. It's easier listening to it while driving or listening to it on my walks. All right, guys. So
I'm like
next I
you,
can.
hard copy guy.
I am a hard copy guy. You see my library, right? Full of books. But
Yeah.
all those books have some equations. Or those books, see, I like literature, literary books I buy, but things that are, see, this sort of book is, I'm sure it's very good, but it is very ephemeral, right? It's of great relevance today. In 10 years, quite likely things would have changed and, we'll be talking of something else. So
Yeah.
this sort of
Mm.
books I
E-
find much
So,
easier to
so
just listen to.
yeah, some of these books, even though those are free, like example, Understanding Deep Learning, Simon Prince,
Yeah.
I ended up in actually purchasing the book
Oh, of course, of course.
just for
Anything
my
with
test.
equation. That book is lovely. I mean, understanding deep learning, and as Simon Prince says, there's irony in the title because nobody understands deep learning. Literally, I'm quoting him. Yeah, yeah. So it's the second thing in my life I've encountered about which I can say, yes, none of us understand. First was quantum field theory, where I spent so many years, and now it is this. All right. So, are 5 minutes over? Not yet. I'll wait a minute. All right, guys, we are about to start. So, here's something I would suggest. Crew AI is really, it's a good blend. I wouldn't call it, see, for example, when you look at emerging things like Sui Agent, etc., they have a lot of very creative ideas. I like Crew AI because it's powerful, it's simple, and for a vast majority of cases, you can get your work done with it quite efficiently. Now, let me get down to very practical terms. This course now, hereafter, will be mostly practice. So, here's your homework. There are three homeworks here. One is there is a course that they mention in their website called multi-agent systems, how to build them. There is this course for which you can enroll at deeplearning.ai. And then, of course, you can also get your badge certificate. So if you're interested, I don't know what happens if you apply for a badge certificate. Oh, start multi-agent system badge. Wow. You have to, I suppose, put your name here, and you could do that. Send me the badge to this email. All right. So I suppose something will happen if you do that. Upload a screenshot of your completion page. So you have to first, I suppose, go here and enroll now at deep learning. Well, in my case, because I have membership here, this should be a little bit easy. Sign in with Google. Yeah, I'll take you through that. 1 second. I'll take you. So, oh, look at this. I have actually, like I usually do, look at all the resources. This is one of them. So I'll walk you through this course, guys. This is a really well done course. One of the nice things with deep learning courses are these are short. It claims to be 1 hour course. Don't be fooled. It takes more than an hour. Right? But it's a very, very well done course. And what it has is, I like this new thing that deep learning has in a lot of their courses is, on one side they have a video, on another side they have a Jupyter notebook. Soon a Jupyter notebook will open up. Right. Now, use the time today. Actually, today I will keep the sessions very short, and use the time today and till tomorrow and so forth to make sure your first homework is make sure you finish the entire course. It's really worth it. It's very well done. It's done by the one, I believe, the creator of one of the creators of CrewAI, if not the CEO. So this one will talk about the key elements of the agent, and you will see that the thinking here is not quite role playing. So remember what I said, that you need to have very clear, like, team members, right? They call it role playing. You'll see a lot of commonality in the way I think they take an example, for example, a multi-agent customer support automation, right? How would you do that? So you create an agent. So let's look at this one thing, and I'll just zoom through this course. If you look at it, you're creating an agent. You're giving the agent a very clear role. So in CrewAI has a very simplified way of looking at it. It says role, goal, backstory. Right. So the context they call backstory, the long. Now, what I would suggest you to do is go one step further. If you remember in the courses we have taken, first thing, role is okay. Don't hardwire the backstory in this code here. Where should you keep it? Remember, as a well-defined prompt in a prompt file, markdown file. That's what we do, right? Remember, we did the in your previous examples, when we did the glossary maker and we did the business plan maker, where did we keep the prompts? In separate files. And our prompts were far more elaborate than the very small. Obviously, this is a tutorial. And as tutorials go, it's already a very well written prompt. But I expect that you would write prompts that's at least a couple of pages long. Your backstory should be fairly extensive, couple of pages. As we are in the habit of doing as best practice, remember, right? We follow our own pattern, somewhat like the CoStar pattern, templating pattern. So follow that. Don't make your backstory this short. Now, let me explain a little bit about how this works. So I'll just use the coding part here. Let's go through this. This is easy. You just have to install CrewAI tools, and LangChain community. So in case you're doing it on your local machine. And when you do this for the duration of the course, you can run it literally on the deep learning's portal itself. But I would strongly encourage you to take this code and bring it onto your machine and run it locally. For that, you just have to install these three things. So this needs explanation. CrewAI is the core library. You need tools, isn't it? Ultimately, if you go back to your reason and act, how would you act unless you have tools? So those are your tools. And LangChain community, what does that give you? So what it does is these people realize that LangChain has a large collection of tools, right? And that's a community there. And so you import that library also. So you're piggybacking on a lot of tooling that has been done, that's available. Right?
Asif, one quick thing here on the same lines on the Jupyter notebook on the left side. If somebody is trying to do it locally, you don't have to basically copy the cells. You can literally bring in the whole notebook from file and download.
Yes,
there is a file download option.
Yes, that's right. Right from here. So you can download it completely and notebook. You can go to the notebooks. Good. Thank you for pointing that. So this is it. So warning, you can suppress the warnings. Now look at that. Actually, I find this line very telling. The way, and this is the first thing that I like, just looking at the imports when I first encountered the Crew framework, the first thing I liked is look at the import from CrewAI, import agent, task, and crew. Right? How well it is. You're defining an agent is a person, a team player, very focused role, isn't it? And look on this side, it is role, a goal, objective, and then the backstory. I would rather obviously write it in more detail than it is here. So an agent has a task to do, a very well-defined task to do. Right. So it becomes a useful in terms of my way of thinking. It has a reason for existence. It has a non-zero Shapley value, right? Contribution to getting the overall goal that it is doing. And crew is the team, isn't it? So team of agents. Everything will be done by a team of agents. An agent will do a task potentially, or maybe a task will be done by many agents. But in the beginning, let's do it with one agent. Rest of it is straightforward. OpenAI, in your case, by the way, is get OpenAI key. No, what you should do is you should just, this should be sitting in your environment for security reasons. Now, here is one advice I'll give you. Use, for the sake of this fun, right, use GPT-4o. Right? They have given it to you with GPT 3.5 Turbo simply to keep it free. Right? But you'll get far better results with the latest. Now, also, a Crew has been ported. I mean, it works just fine also now with Llama and Mixtral and all of that. So there's a fairly rich ecosystem now. Right? In fact, in my opinion, remember in the last time I said that the beauty of agents is using small models, you can, and agentic reasoning, you can achieve the same power as the large model. So start by using GPT-4, but in a way, it defeats the purpose. Later on, once you become good at it, use Crew with small models, right? And you will achieve pretty powerful results with that also. Let's look at the role, and I'll just walk through the code here. You give it a role, you give blah, blah, blah. Allow delegation, right? So it means this agent is a foot soldier in the team. You can't delegate, right? It's a leaf level. If it is given a task, it has to do it. Verbose means whatever it thinks and acts, it has to keep printing it out to the console. That's all it is. Like next. So are we clear with this, guys? So observe the things. It uses a slightly different language than I use. But role playing, I call it specialized specialization, right? And clearly defined goals. Focus, important. Cooperation. What we will see is that there are two. Okay, so here's the thing. Support agent and there is a quality assurance agent. Now, remember, I talked about this fact that even these LLMs, they can generate things, they can do things, generate an answer, but they are also very capable of critiquing themselves. So in many of these solutions, you'll see, and it's a good practice, for everything that somebody does, have a supervisor, have a critique, right? Now, it's common to have the critique as usually a supervisor or a QA, quality assurance person. Does it make sense that if somebody is a senior support representative, then somebody is a support quality assurance specialist? Make sure that the support being given is good. Are we making sense? My way of looking at it is now you're using the critical power, the discriminative power of the LLM, right, to critique its own work, because ultimately it's the same LLM putting on different hats.
Where does the LLM as a judge come into the picture here, Asif, in this context?
Oh, each of these agents is a LLM. So this one is the judge. You notice that. You look at this. Your work at CrewAI and are now working with your team on a request from ensuring that the support representative is providing. So look at this part of the sentence. Ensuring that the support representative is providing the best support possible. Right? So this agent is critiquing this agent. You're getting it, right? The senior support representative will do the work. And this agent, support quality assurance agent, is the critique that will critique the work of the support agent. And a little bit of a trick, by the way. See, look at the play on words. You're not calling him the support representative. You're deliberately implying that the person is very experienced by putting the word senior there. Right? So these are the tricks, of course, of prompt engineering that do make a difference. Like you're making it wear a good hat, like saying you really do a good job from experience. And nevertheless, you have a critique which will critique its work. Whether you got that one, this part. Right?
Got it, Asif. Thank you.
So this is it. This is it. The rest of it is straightforward. Now you need some tools. Right? How would this agent go about answering a customer problem? Right? It needs some tools to do the work. So it is given a search. Serper Dev tool is a popular, basically Google search, converted into a tool. You need to have a key, just as you need an OpenAI key. You will need a Serper Dev key. Some tokens are free or something like that. There's a fairly low, but it's fairly low cost. You can go with it. There's another tool to scrape website. A scrape website will go scrape the websites. It does pretty good job. You can be very careful and you can just give a partial URL and limit it to a certain area, or you can give it, so things like that. And website search tool will search a particular website for something. So these are the tools. You can have more and more and more tools. But see, guys, the power of these frameworks is not in the tools they have. I mean, they have a lot of tools, very empowering. But the real power, the superpower comes from, guess what? Everything that you have coded, you can convert it into a tool for this framework, isn't it? For example, let us say that you have a way to compute, right? Looking into the database and blah, 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 and coming up with, okay, what lunch should be served today in the cafeteria? Well, you can write a cafeteria tool. There is a base class called base tool. Just extend it. Basic object-oriented programming. Extend the base tool. The only requirement is that in the class that you create, your Python class that you create, you must give a name and a description, because ultimately the LLM, these are LLMs. They need to read what exactly is this tool supposed to do. Right? So that's all. Now let's create tasks. So you have created people. Think of agent as people. You have created two guys. One is the worker B the sales representative, support, yeah, I mean customer service guy, worker B, and one the boss who just hangs around and critiques. Putting it simply, right? And then now let's go and uh, give it some task. What is the work that you will give to the worker B? Right. Some it will be a task that customer just reached out with an inquiry. It's a person. So a customer could be like, let's say, Amazon, right? And a person like Henry from Amazon reached out with a question, right? And so your task is make sure to use everything you know to provide the best support possible. Right? So you notice that this is a little bit redundant because it covers or some things that you are here, which also says use everything you know to provide the best support possible. But here it's a explicit hint to use the tools. You must strive to provide a complete and accurate response to the customers. So you can pretty much guess who is this thing targeted towards? This task is targeted towards? Obviously the support guy, the worker bee, right? Right. This is it. And what tools is the person allowed to use? Well, you can go scrape some URL. It just says that you can get the answer from this website, this web page. Right? You could be more restrictive. And then you have to also say, if it is a task, what do you expect? What is the outcome you expect? So you say the outcome you expect is a detailed, informative response on the customer's inquiry that addresses all aspects of their questions, blah, blah, blah. Right? But see, this is the problem with LLM. How often have you invoked LLM and said, no, no, this answer is not good. Let me review it. So who is the critique at that moment? You. You're in the interactive loop with the LLM, isn't it? With the chatbot. But here, who is the critique? The critique is the boss here, the quality assurance guy. Right? What does the person do? Let's look at the language here. Review the response drafted by that senior support representative. Let's call the worker B. Ensure that the answer is comprehensive, accurate, and adheres to highest quality standards expected for customer service. Verify that all parts of the customer's inquiry have been addressed thoroughly with a helpful and friendly tone. Check for references and sources used to find the information. Ensure the response is well supported and leaves no question answered. Right? Now, once again, guys, even the task descriptions, it should never be hardwired in Python code like this, in my opinion. Where should it be? In separate markdown. Because what in really will happen is, and this is part of the ML flow and ML ops and so forth, people will be tweaking to see how they can improve the product, isn't it? And the easiest way to improve the product is just change the texts. So keep them in separate files, text files. Don't keep them here.
Asif, this style, if it's modified, I don't think it will work properly, right?
Say that again, please.
So this seems to be like a hardwired style of
Very
doing.
much, very hardwired. Yeah, it's hardwired. See, obviously they're trying to teach you, so they have kept it simple. But since you guys are much more bigger experts at prompting, follow the best practices that I've taught you. Keep them in separate files so that they, like as you pointed out, Ravi, versioning and many other things come in the prompts. Exactly. Oh yes, yes, it is. If you were taking the absolutely. If you're taking the MLOps course, literally that's one of the topics. Like how do you take different versions of the prompts and compare it to what performance metrics are associated with that? Yeah. So model versioning, prompt versioning, that whole topic is called prompt ops. Just like from DevOps came MLOps, now from within MLOps is LLM ops. Now within LLM ops, there's prompt ops, right? Of which that is a topic. So this is it. And you're giving this task, obviously, to the boss. Now what do? You have two guys, the worker bee and the boss, right? The doer and the critique. And it's always a good idea to have critiques around, right? Why? Because LLMs inherently are very good at critiquing their own work. So that, now each of them have been given a job. They have been given things to do, right? Now what is needed for them to run? You have all the ingredients needed to create a crew, the team. You say the team is made up of these two agents. These are the tasks. Verbose is verbosity level, how verbose you want to make it, pretty verbose. And then memory is equal to true. Remember, to do work, you need memory. Even in the React, you notice that React paper just now you saw that there was a context, isn't it? You need to preserve the context of the work as the work progresses. So memory, of course, has to be there. Always have memory is equal to true, unless there's a reason not to. That's sort of have a default habit of. And when you're writing code, have a pretty high verbosity. Right? You want to see every detail of how the machine is thinking, isn't it? So do that. Running the crew. So how do you do that? Now the crew is ready, except that we don't know who the customer is, right? Who the person, which client it is, which person it is, and what the question is that the client is having, support question the client is having, right? So we need to input that. So yeah. Yeah. The task, this is it. One task for the worker B, right? And one task for the boss. And there we go. And then now we need to give this. So we take an example. Suppose it is deep learning and a person is Andrewing. And here's the thing. I need to help with setting up a crew and kicking it off specifically, blah, blah, blah. Right. So you can then run it, and I'll just run it here. Let's see what happens. So you notice something interesting. Inputs, result, the main thing firing off the program is crew.kickoff. Right? And observe one thing, guys. Once the crew has been created, you can have it run sitting somewhere. And inputs, can you give these inputs, for example, as a REST API? And so this entire multi-agent thing that you have written now just became a microservice. That's the beauty of it. You see that, right? And so that's your goal. So that now happily brings me to giving you another homework. What could that be? The glossary that you have been making in the business plan maker. So just take the glossary. I want you to have a microservice in which you can give a topic, a subject, the number of glossary items, top n, that you want to, those are the two arguments, right? And what it should return back with is the glossary. The same exercise that you did previously. And do that. And the second part that you would do, which not yet, because that will come in multi-agent collaboration. We'll keep it the homework for next week. But guys, do you realize that this is a very simple homework? Using just what you have learned so far, you can actually do it now. The glossary part, right? Search the web, search a textbook. When you search a textbook, it becomes RAG, isn't it? So RAG, as far as multi-agent collaboration is concerned, RAG is simply a tool for you. Where does it fit in? It is certainly not an agent, it's a tool, right? The whole RAG with its LLM involved inside it is just a tool for you. Right? Or another way to think of it is, if you consider the agent to be there, then to the agent, you can give search into files or search into a search index, a semantic search index as a tool. Right? You can define it many ways, but this is it. But now let's look at how this machine is thinking. It says debug, working agent. So who's the guy who will start working? Obviously, the worker B has to work before, right? Worker B starts and says, okay, starting task. Deep learning just reached out with a super important task. Ask, I need help with setting up a crew. So this is the exact query, right? I need help, blah, blah, blah. Can you give me the guidance? Right? Then see, this is the think part. Remember the React, you had the think part, right? Is this the think part? Is the worker working, the senior support representative thinking at this stage? All the way here. This is what it is inferring from the input. Is it making sense, guys? Right? It did that. And then it says, what's the next thing we did? It acts. It does something, right? Entering a new crew agent executor task. Executor chain means Now it is going to actually do something, right? So behind all of this language, you can see the resonance of the previous a simpler paper. I need to provide the best support possible to deep regarding their question on setting up a blah. I should use the tool blah, because it turns out you gave it only one tool, so it doesn't have much choice. It will go read that page. Then it says action, read content, action input this. So it goes and reads the whole web page content, which is pretty extensive. Then it, where is the end? Okay, so here's the thing. This is the end of that. So, no. I think, did I run through too fast? Okay, yeah, here it is. It is reading this. This purple is the page. Final answer. It comes up with this answer, but after reading that page, it says, "Hello, Andrew Ng from Deep Learning. Thank you for." So you just look at the title. Is this how you would like to be addressed? Hello, Andrew Ng from Deep Learning AI. Probably not. It's a bit too verbose, right? So obviously some criticism is needed. Thank you for reaching out for assistance in setting up a crew and adding memory to it. To help you with the process, please follow the detailed steps below. Create a crew, visit this document, follow the steps, adding memory to the crew, blah, blah, blah. By following these steps and utilizing the tools provided in the crew documentation, you'll be able to successfully set up your crew and memory to do it for enhanced performance. If you require further assistance or have any specific questions along the way, feel free to reach out to us at any time. We are here to support you, blah, blah, blah. Does it feel very boilerplate-ish and typical LLM output? Default output, right? You have that. Then you finish the change. Then debug. The agent says task output. Which is it? Creating this, etc. Just repeating the information. Then debug. Working agent. Now comes the critique, right? The critique, the quality assurance specialist. It says starting task, reviewing the response drafted by the support representative for deep learning's inquiry. See how well it is able to think through what the thing that is there. Ensure that the answer is comprehensive, accurate, and adheres to the high quality standards expected for customer support. Verify that all parts of the customer's inquiry have been addressed thoroughly with a helpful and friendly tone. Right? Check for response. So this is the task that it has gotten. It's just repeating the task in this context. So it goes into execution. It says, okay, let me act on it. So it says, how do I act on it? I need to thoroughly review the response drafted by blah inquiry to ensure it must be of the highest quality. I should pay attention, blah. Action. So then it comes up with an action. It says delegate work to co-worker. And it says to which co-worker? Back to the worker B, to the representative. And the task is review and revise the response drafted. Now, why could it delegate? Because if you, and this is a subtlety worth looking into, if you look at the nature of the thing, we didn't say allow delegation is false. For the worker B, we said you can't delegate, but we didn't say, we didn't prevent this guy from delegating. So it goes and delegates. It says that you need to do a better job, basically, right? Delegate, review context, review the response to ensure it is comprehensive, accurate, etc. So it basically, all it says is that it doesn't actually review it. It says you review it yourself, right? So now what happens? It says, entering new crew. I can give a great answer, final answer. Thank you for reaching out, blah, blah, blah. Yeah. So now do you notice that the answer is improved? It is not asking you to go to the second time. The representative actually does some job. Instead of just pointing you to the documentation, it is actually giving you the specific steps. Do you see the difference between the two? Yeah. This is just saying. Yeah. So what happens is that the representative is forced to acknowledge that its answer may not have met all the criteria, right? And so it comes up with a different answer this time. And that's all you have to do, just bounce it back, which is typical managers, right? So the first reaction is managers don't even bother looking at his code. If he checks in some code, just say, bad, do it again, right? Pretty much like that. And so now this answer gets better, blah, 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 do all of this. And then now I can give a great answer, blah, blah, blah. This is the answer and finished. Yeah. All that the critic did is just bounce it back to this guy. It's like, yeah. So 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 this is a very basic example, but basically there's something called turns. How many turns you want to play this game, and so on and so forth. So in just one round game at this moment, right? So actually this is as basic as it can be, because what you should have is some real checking whether everything has really been met and blah, blah, and so forth. So now you get this response, and you would agree that this response is better. Right? So this is a basic example of how Crew. But by the way, do you see the sheer simplicity of this framework, guys? And its power. It's very simple and very powerful, isn't it?
Beautiful.
Beautifully done. Right? This is it, and this is it. So let's look at the mental framework. What are the things that you should have in a framework like this? What is a goal? What kind of? It's basically the sort of things that I've trained you to. So I won't go into that. Okay, I won't go into the actual thing. Suffice is to say that pretty much all the things that I've taught you, you'll find that they recommend some things more or less along those lines. And tools. Tools are very important. Remember, the superpower of agents comes from the tools they have, right? Just like us human beings, right? Give us a very fancy camera, like a mirrorless big camera with lenses. Even you and I can take better photographs with that. So it's all about tools. How good your tools are. So go heavy with tools, guys, and learn to create your own tools. So this is an example of how to create custom tools. So suppose you want to add a sentiment analysis somewhere, the hello world of all NLP tasks. So what does it do? So what are the core things you need in a tool? I said you must extend base class called base tool. You must have a name and you must have a description. Those are necessary. And you have underscore run, and inside it you can put whatever you want, right? And then all you do is in the tools, when you give the task, you can make that tool available somewhere to something. Yeah, right. That's it. Yeah, right. But you don't have to. I mean, you can be fancier, but I mean, the default base tool is text. Now, one of the things you could do is that text actually may be a JSON, for example, that you can use Pydantic to convert it into a data model, base model, or something like that. Right. So you can get pretty fancy. And that brings me to the next thing. CrewAI has a first-class integration with Pydantic. Just like Instructor, remember we did? It has a very good integration narrative with that. So you'll notice that it plays very well with a lot of things. You can do event planning. You can do financial. And by the way, they give this example of financial analyst, and the speaker, I think he obviously has seen CrewAI being used. And he said that first he gives the warning that by no means this is the way you should analyze stocks and give stock advice to people. And then he goes on to say that actually, you found that a lot of financial institutions literally use CrewAI for this, for analyzing stocks and making recommendations about it. So I will just run this. What it does is that in this example, there's a data analyst, there is a strategy developer. This is what you do in a financial institution, right? Somebody will analyze, get the facts. Somebody will develop a strategy. Somebody will create advice, trading advice that do this. Somebody will then say, no, wait a minute. There's some risk associated if you do this. Risk advisor. Does that make sense, guys? Would it make sense if I did not read all the descriptions, backstory? You all know what it is, right? Data analysts will just go look at the ticker symbol and all the news and everything that has been happening. trading strategists will develop, okay, you should buy, sell, whatever it is. Then trade advisor, so on and so forth. So let's run this. Tasks are exactly what you would expect, right? And now there is one new thing that you notice, that now all of these guys, right, they are all horizontal in some sense. Once this guy has worked, you realize that there's a need for these guys to collaborate with each other. For example, there is no point in making one trade advisor saying, excellent stock, just go buy it tomorrow. And the risk advisor saying, please stay away from it. Right? They need to have a aligned recommendation or something like that. So what you do is, these are the worker bees. You notice that the boss is missing here. Right? In this role, the analyst will get facts, the strategist will build a strategy, right? Advisor will give the advice, advisor agent, and risk advisor will tell you about the risk. Trading one will give you. So you need a boss, isn't it? So one easy way to create an implicit boss is to just say in these things that there is a concept of a process. You say hierarchical. The moment you say hierarchical process, what it does is implicitly it creates a boss who orchestrates or coordinates the collaboration between them. Right? So there's sequential processes, hierarchical processes, etc. There's a lot of detail, but I'll just run this and you'll see what happens. So what is the input we are giving? Stock. Oh, Apple seems to be a favorite. Let's go with something else. NVIDIA is the... Does anybody remember the NVIDIA stock? NVDA, right?
NVDA.
Let's try NVDA. That should be better. So let's try that. We will restart and run. Okay, we'll start with this. The results have just come out. Let's see what it recommends. All the guys doing AI, of course, are obsessed with NVIDIA stocks. So we'll find out. So most of it is easy, but you realize that this execution is obviously time consuming. Right? So remember, when you create your microservice, make sure that it's async. It doesn't block. Right? So it is entering a task, start continuous monitoring data for the stock NVDA, use statistical modeling and machine learning to identify trends and patterns. So the crew manager. So now, do you notice that a guy called crew manager has come? A boss has come. Then it comes to the conclusion that I need to delegate tasks to the appropriate team members and ask right questions to ensure we gather the necessary insights for NVIDIA. First guy is, of course, the data analyst to gather data. So next, now the data analyst starts working, goes and reads what? Reads a website. Here we go. Right? Input thing. Where did we get that? Somewhere we must have given it. Either that or it just went and searched and figured it out. Yeah. It just it used the search engine and said, okay, this is where I'll go. Right. It found this and it found this text there in purple. And from this text, now it thinks. Green is thinking. Final answer. NVIDIA core processes, blah, 3D, blah, InfiniBand, band, and spectrum, blah, 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 etc. It thought through. Then what happens? Then it has a thought. Right. I need to gather insights from the team to identify significant market opportunities or threats. It says, ask question from coworker. So now the manager goes to the strategy developer. Right. What will the strategy developer do? It will say, okay, let me go get going. It will read the results that you just got from the website that the analyst brought you. And then it will say final answer provides blah, 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 blah. And somewhere in there should be a strategy. So then debug crew manager output, NVIDIA Corporation provides blah, blah, blah. Entering the next one to the appropriate team member and gather information from them to develop trading strategies. So which coworker do you give it to? Data analyst, task, blah. And so there are a lot of debug statements. It's a little noisy. The output's a little noisy. So, but let's look at the final result. Let's look at this. At the end of it, what comes out? Right? Risk analysis report for NVIDIA. It says, introduction, the proposed trading strategy for NVIDIA involves a combination of long-term investments and short-term trading approaches. So there's a trading strategy here. Right? This report aims to evaluate the potential risks associated with these strategies and provide recommendations for effective risk mitigation. Let's say long-term investment strategic risk. It says market volatility. NVIDIA's performance in the AI and GPU market is subject to market volatility, which may impact the value of long-term investments. Do you agree? Seeing what's happening recently? Competition in the gaming, data center, and automotive sectors may pose challenge to NVIDIA's growth potential. So it has done the research, isn't it? Regulatory. Changes in regulation related to AI technologies. See, it got even that one right, and data privacy could affect this. Government puts one more ban on those chips, and the stock will be affected. Mitigation recommendations, it says, spread investments across different sectors to reduce exposure, continuous monitoring, blah. Risk hedging, use option trading as a hedging strategy to mitigate potential losses, short-term trading risks, etc., right? So effective. Let's see what happens if I gave it Apple, which is a little bit more stable. And that was that? Yeah. Yeah, let's see that. Yeah, you can do that. So guys, I hope by now you realize the power of using agents as opposed to just prompting an LLM that you're doing. This is what we started the course with, that agentic reasoning is very powerful. It leads to a lot of very effective results. Okay? And they mean it actually. When you watch this course, the instructor here mentions that lots of companies are using it literally for what he advises, don't use it for. So yeah, there we go. Apple. Oh, Apple, blah, 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 mitigation strategies. Overall, the risk as highlights the importance of being vigilant, informed, and prepared to navigate, blah. It does sound a bit generic. That's true. It does sound generic.
So as if the output is not consistent. It doesn't have
Yeah, it
few
is
things.
not.
It is, yeah.
Yeah. So, and this is the nature of this, which is why, of course, it is good as a small tutorial when you would actually do it, and I would expect better standards from you, because obviously goal of the instructor here is to make it simple so people can understand. But when you take it to production, anything, it has to be a more involved approach. Yeah, go ahead.
Asif, one concern I have with this, right? Is this, let's look at it from an enterprise perspective, right? I mean, this is great multi-agent and agent collaboration, all of that, like a teamwork. The concern I have is that how is the multi-run is going to be, from a results perspective? Like, if I run the same thing with the model, is that going to give me the same response, right? Because most of the enterprises are auditable, right? From a compliance and all that standpoint. That's my biggest concern from the agent's perspective. I mean, the creativity is great from, generation is great, but, will it produce me, the program will produce me the right, same response, multiple runs, but will this do it? Because the models we know.
So it's not deterministic. See, anytime you use a LLM, determinism goes out of the window. Right? So that looks like a pretty bad statement. But now let's parse it. This is a basic example. Okay? because they're teaching you this topic and so forth. A very excellent example, by the way. But when you were to really do it, what you would do is you would put a lot of guards and constraints. So what happens is that even though the answers may be verbally different, semantically they have to come out the same over and over again. And you can more or less constrain it to do that. So that speaks to your regulatory aspect of it. There are ways to do that. Not perfectly, but for all practical purposes, you get there. Right? Now here, the prompt itself is very basic, right? They're teaching you. So obviously, you don't have a very complex set of safeguards and system prompts and rules and this and that and multi-step. And also, it is doing, frankly, in my opinion, it's doing too much. Each agent is doing too much. It needs to break up its task into many, many subtasks, right? With predictable results. Right? At this moment, right, you realize that these are one shot. The analyst goes, analyzes, comes back with the result. It's done. Right? Then the strategist goes about it and so forth. So for one thing, do you realize that in this example, unlike the previous one, the critique isn't there. It's just collaboration. There's no critique here. Right? And so that speaks to that. And so obviously, as an example is very good, but a learning example is good. In production, you wouldn't have it as simple as this. One second, Hamad, go ahead. Yeah. Yeah. Okay. Okay, very close to human intuition. Yeah. So Hamad makes a point that one of the ways he has observed to improve the performance of these crews, these agents, is have them do very human-like conversations, like send a text to that fellow. Right? That fellow may be another agent, but you use very human-like language, anthropomorphic language, or anthropomorphic behavior. It seems to help. It's a great point. I agree with that. That's very nice insight, actually. You were saying something? Yeah. Yeah, it doesn't serve. Yeah, the whole thing, yeah, that is definitely true, but it does cause angst, right? So, for example, imagine a doctor who every time you ask him, now tell me what's wrong with me, and he gives a different answer, right? But see, if it says now you have diabetes, and next instance it says no, you have heart disease, that's worrisome. But if it says the same thing but in different words, semantically is the same, then it is not worrisome. And LLMs with proper guardrails and frameworks, you can constrain it to say the same thing over and over again, right? Just different words. Yeah.
So Asif, there's another course here.
Yeah, one second, Albert, 1 second here. There's Ravi is sharing his experience here. Mm-hmm. Is there any condition of I'm having the pre-diabetic? So the answer is, yeah, you have been pre-diabetic. However times, whatever things you have been asking it, this is. Yeah. So I'm saying that if it can determine that, the chances of diabetic, it always gets. Just because it is coming from the neck and where it made that conditions based on the diet. Exactly. Yeah. You really get a deterministic, and then yeah, it does that. Yeah, it does that. Yeah. So what Ravi is pointing out is that if the data is hard that goes in, and from the web it has configured that, learned that, then the LLMs do come back with the same answer over and again. I agree. In fact, LLMs are being used literally to do discriminative tasks like classifiers, right? A lot of people are using LLMs as a classifier, zero-shot classifier. It's one of the very popular uses. So obviously, if it is a zero-shot classifier, you have to have reasonable assurance that it'll pick the same. It won't once call it a horse and then a zebra. Right? So, Albert, your turn. You're saying something.
Yes, there is another course in deeplearning.ai, which is very good, and it's similar on agents. It's called AI Agentic Design Patterns with AutoGen. That is beautiful.
That is right. That is right. And I've done that too.
Okay.
But again, let's not jump the gun, because that is an assignment coming for you. Yeah, not next week, 2-3 weeks from now.
Okay.
Because I'll take you through all the frameworks, guys.
Okay.
Well, not all the frameworks. It's not possible. There are too many frameworks, but all the leading frameworks that I mentioned. And now Madhu pointed out that we should also include SWE agents. I'll try to include that also.
Thank you.
SWE agent. Right. So this is it, guys. So but here's an example. This might not be very impressive, but the next example I consider much better. It's really a good example. See, what happens is people write their resume. It is reflects who they are, right? Most of the time. And you have the same resume you keep forwarding to all the jobs, right? All the companies. And the hit rate is whatever it is. But what this is, it says, okay, first look at a job posting, right? And still staying within the facts, not like cooking up fake skills. Refactor or rewrite my resume to resonate, to make it more appealing to that job, right? And that is what this is about. And it does a very good job. I will explain that. See, what you create is a researcher which will go and look at a job, find a job. Having a job, personal profiler for engineers, blah, blah, blah. I'll give you the end result. You can read through the whole thing, but the end result is quite impressive. What it does is it takes your resume and given a job profile, completely rewrites the resume to make it much more attractive to that job profile. Right. And the results are very nice, actually. Very, very nice. And this one actually is, in my way, much more impressive than the previous one, right? The financial stock thing. And it does a pretty good job. And not only that, it even gives you practice questions for the interview. Like what questions to prepare for an interview for that job that's been offered. And I thought that was really neat, the way they did. So guys, can I expect you so here are the homeworks. I'll end early today. First is, can I write it down? Let me write it down. The 4 pieces of the, um, definitely. Actually, why don't I write it in the portal? That's more sensible, because why write it here and then do that? Let's go here. Um, lab 1, environment setup, lab 2, setup, React. So let me go into edit mode. Obviously, now you're seeing a lot more. I'll add a section, homework. Where's the section gone? React, yeah. This is a second homework, I suppose, or third homework? Third. Homework 3. Let's go there and let's write it out. You realize that by homework, I mean something that you would have it done by Tuesday when you'll review this. Mm. Next part of the homework is Is it making sense, guys? So these are the 3 pieces of your homework. There we go. Now, this is what you should see. Homework 3. By the way, are you guys having fun with this course? Is it looking fun now?
Yes.
Recording is still on. If you want to stop.
Okay. Now I should stop the recording.